This place is actually a monastery in Taipei. You can't rent it out, unfortunately. I wish you could. But it's a nice segue into the talk. Hi everyone, I'm Phil. I'm a second year PhD student and researcher at IC3 and Cornell University. And I work on smart contract security and distributed systems security, including distributed systems protocols. And I'm here to talk to you guys about incentive compatibility and rent. So these are some notes that I had from last time. We had a little workshop in Taipei about rent, and I'm just going to talk for like 3 or 4 minutes, go through this list to give you some really high-level background, and then we can jump into more of a roundtable discussion where I want to have like a lot of people contributing and participating and saying controversial things, because this is an important issue. And I think what we have an opportunity to do here is converge on sort of some of the immediate reactions people have to rent, as well as potentially insights into which mechanism is preferred by the community and by developers. All right, cool. So let's talk about blockchain's dirty little secrets, and it's not IOTA's ternary or EOS's block producer cartel. It's basically the fact that every blockchain right now consists of users doing transactions on a network. And what this essentially is a two-sided commodity market between users and people who are running the network. So like miners, full nodes, etc. Sometimes these categories overlap, but not always. So this model is kind of flawed because right now miners decide what transactions are included and they're not the only ones bearing the cost. For example, full nodes are not incentivized. And the computational model that's charging these fees is overly simplistic. It sort of approximates costs at a rough cut, but it doesn't really have any deep insight about what these resources should cost or any way of responding to sort of market changes. There's a huge reliance on commons, so a lot of things people are doing in blockchains right now are not incentivized. They're relying on this commons model where people are being nice and altruistic and are doing it like mostly for free, or because they have some other reason to do it for the moment. Resources, as a result, are currently massively underpriced or subsidized, however you want to see it. So when you store something on the network today, it costs you a few cents at most. And the reason it's so cheap is essentially because you're externalizing this cost onto everyone who's running the network now and everyone who will be running the network forever. So we saw Alexi's graphs earlier about the sync with like the DOS attack. And like that was sort of a temporary blip in the network history, but it's something that client developers and especially people who want to run these archival nodes potentially may have to deal with forever. So we need to enable more efficient marketplaces. That's my theory. And there's a projectchicago.io webpage here if you want to read more about the like overarching project. But I won't get too into it because I want to have, like I said, more of a discussion. So today we're going to talk about storage rent. Storage rent is a pretty simple idea that's been around in Ethereum for a while. So there's a bunch of background under the agenda. It was originally proposed in EIP 35, which was, let's see exactly, April 3rd, or no, even before that, November 25th, 2015. So like early days of Ethereum. So this isn't a new issue, but it also hasn't happened yet, and that's one of the things we're going to talk about today. All right. So it's worth noting that last time we talked about this in Taipei, it was kind of a heated, controversial discussion, and of course the next morning, we all woke up to this. Which is not really exactly what happened, but let's all agree to pay together rather than having anyone decide. All right, cool. So I guess let's start with a rough sentiment of the room. Like, how many people here are aware of blockchain state and what it is? All right, how many people know the difference between state and history? Okay, most people. That's great. How many people here use the Ethereum mainnet like on a regular basis and pay gas on the Ethereum mainnet? Okay, good number. All right, cool. So I think we can skip some of this background issue, but maybe we can start because this is a client dev meeting. Are there any client devs or anyone else, any researchers who want to talk about how large state can potentially like negatively impact users of Ethereum? All right. This whole section is going to have something to say. So let's
as I showed you this morning, I was trying to estimate the state, how big the state is, and at the moment it's not that big. If you were actually store it in an optimized way. It was about 10 gigabytes, which I think could still be further compressed because the state has got a lot of repeating elements, like somebody's addresses as a token owners. That could be further reduced. So it's still possible to keep the state in memory on most modern machines. However, there are some people in the ecosystem who do need the access to the history. Some of them need access to the recent history, and some of them need access to the much further history further down. For example, for some reason, I'm not sure if anybody from Raiden is here, from BrainBot.
There's an off-chain workshop going on today also, yeah. So I think they might all be there.
When I was at Full Node and I bumped into this guy, Conrad, what he was doing, he was trying to retrace, for some reason I don't know, he was trying to retrace all the transactions that ever happened in Ethereum. And he said, by his calculation, it's going to take him like 6 months to do that on Go Ethereum node. And he obviously needs a whole state. I mean, the exchanges need some of the state to monitor the deposit. The block explorers obviously need the full state. And so yeah, the state growth does have an effect on most of users through these participants in the ecosystem. Everybody likes either scan, but you know, they have to maintain this huge archival nodes.
Yeah, and to just comment on that quickly, I, for example, would need to do something like what you said, retrace every transaction in some range of Ethereum, and here's like a concrete reason for it. So like one of the problems we're studying right now is like how much rent are users paying in the system on like decentralized exchanges to arbitrageurs, for example. And to study these marketplaces, you also need to know when people like try to make failed transactions to them, as well as making successful transactions. And because failed transactions don't have any side effects on the parts of the state that are easily accessible usually, and because these transactions can be like intentionally complicated and obfuscated through contracts, there's actually no way to know like a full picture of this marketplace without rerunning every single transaction and checking like, does it call this contract? So I agree with you. I think a lot of people have needs for both kinds of storage. Vlad, maybe? No? I saw. We'll go around here and then open it up.
I mean, if you need the history, maybe you can keep it, but the issue with paying rent on history is that, well, I mean, then obviously we're not going to keep it if you don't pay rent. And that's kind of contrary to, so somehow, what I'm saying is, we can't really charge people rent to keep something in the history. We can only charge them to keep it in the state. And so I'm not sure that, we should, like, as a matter of core protocol, support.
Yeah, I agree.
At least for all full nodes, the whole history.
So I think today we're like scoping out to mostly state rent, but it's worth like thinking about history and how that's not incentivized, and maybe also making it somehow incentivized in the future, or just making sure as a norm for the community that it won't ever be like unstorable to anyone.
So just something out to this history discussion. You maybe remember the talk by Abihu from yesterday, from Starkware. So he was presenting a use case, which is the shielded transactions on Ethereum. And in his use case, you might remember that the biggest cost was, at some point, was the store operations, to store the nullifiers. So that was actually, I was trying to refer to it in one of the dev calls. So, and I started to think about it, but for his use case, he kind of needs a history, but without, he doesn't actually need a state, but he needs a history. If there was another type of storage in Ethereum, which essentially you can write once and never update, which is kind of the history thing, and it was cheaper than let's say than mutable storage, then that would be very beneficial for that use case. So there might be a benefit to having like another type of storage which is immutable.
Mm-hmm. Interesting. Yeah, so I think more storage types are for sure cool. Do you have something? No? Okay. Anyone wanna add to that at all, or? I'm gonna stand here awkwardly for 30 seconds before I move on, so. This makes the default option contributing rather than staying silent. All right, it failed. All right, Cool. So let's see. We all already kind of know about that, so let's skip that. All right, so I guess this is a good philosophical question. We hear a lot in the blockchain space that what we're trying to do here is build protocols that have crypto economic security. So does anyone here have a very precise definition for what that actually means in practice? Yeah. We'll go Vlad then Vitalik because his mic is closer.
I usually think kind of about two things. One of them is like, oh, is it an equilibrium? Like, are the protocol guarantees, or is following the protocol in equilibrium under various models? And then I ask, is that equilibrium robust against external incentives?
Okay.
And that's like the basic kind of story. Making it precise is a little tricky because you gotta say exactly what the protocol guarantees are.
And what robust means.
Well,
you have a definition for it, I know. That's not
yeah,
what I'm challenging.
I mean,
yeah.
You do have to do that, for sure.
Yeah. Oh.
Mine is basically
Take the mic.
a small part of
It's live stream. People want to hear you. It's for the people.
So a small part of my, or a significant part of my definition is basically how much money does an attacker have to burn in order to cause some particular metric of the quality of a protocol's execution or user's experience to decrease by a certain amount.
And by how much they have to spend, you mean like minus their expected profits, or?
Yes.
Okay.
Either minus to their profits or plus to their losses. It's like equivalent.
Okay, yeah. All right, cool. So I guess in your definitions, do you think the current storage model is crypto economically secure? And if not, what could go wrong with it?
Well, if the intended equilibrium is for people to use the state space sufficiently, then I think it's not an equilibrium. Maybe we should mention gas token.
Yes.
Gas token is this great
Thank you.
DApp that lets you store a bunch of things in the state, be it a contract or storage, and then clear it when the gas price is higher for a discount. And so, like, there's actually incentives because the volatility of gas price to store junk in the Ethereum blockchain, and you can do it today, and it's very rational.
Disclaimer, this is not an investment offering or financial advice of any form. Nor is it an offering.
Yeah, and I remember I came up with a list of issues with the gas mechanic as it relates to storage a while ago. So some of them are that, like basically things that prevent it from reduce its crypto-economic security. One is that in an absolute sense, storage is underpriced relative to the externality that it imposes. But like that's only one thing, right? If that was the only problem, then we could just like bump up the gas cost of S-Store by a factor of 10, call it a day. The second problem is that there is insufficient incentive to clear storage if you have ever produced a storage. The third is that there is a mismatch between the volatility of basically the volatility of the price and the volatility and the externality. So like gas prices are 10 times more expensive when lots of other people are setting transactions at the same time. And you could kind of make a case possibly that there's an economic model under which that's happening because at that particular point the cost to the network of accepting even more transactions actually is 10 times higher. But with respect to state storage, that's like not true at all, right? It actually doesn't really matter if you fill up a megabyte on Tuesday or fill up a megabyte on Friday, or even if you fill up a megabyte next year. And then some of the some finer issues basically are that the gas costs for storage should in general, first of all, the gas cost for storage should not depend on the level of usage of the extent to which other people are filling up storage right now. And the other thing is that the gas cost of storage should not depend on the extent to which people are doing non-storage related things right now. So like between all of that put together, there's basically this large incentive to, first of all, do gas token type arbitrage. Yay, Phil.
We own 5,000 blocks, by the way. Not
Second, to basically do state storage filling whenever the gas price is cheap. Third is to very often underinvest in clearing. The fourth is, and then there's more complex examples, but they basically boil down to gas token.
Okay.
Another kind of desiderata that we haven't mentioned is like, oh, maybe we don't want the state to get too big. We didn't really mention that. Like maybe an equilibrium that we want is like, oh, maybe the state doesn't get too big.
So how do we define too big?
You pick a number and I will accept it.
The Bitcoin Core approach?
No, you have to pick it, Phil.
I have to pick it.
Yeah,
I have to pick it. Okay. Yeah, that's true.
Absolutely, because
yeah.
he doesn't even give the same numbers as they do.
That's one way to do it, I guess. Everyone in the room is cool with that, right? Show of hands? No? Okay. Me just picking how big the state should be for everyone on the network.
Just an upper bound, not. I mean, it could be smaller.
We should, yeah. It should be like one of those little balls that you used to throw around for the prompt.
I think those exist.
Yeah, aside from the long-run equilibrium and finer issues, there's this gaping underbelly, storage bomb attack that was outlined in a 2015 least authority paper. I mean, all it would take is, one mining pool to get mad at Ethereum, and, there's nothing to stop them from blowing up the state like the, Shanghai DOS attacks.
That reminds me of incentive misalignment number 6, which is that in the case of bandwidth and computation, miners have an additional disincentive against including transactions, which is the incremental uncle rate, whereas with storage that ends up not existing at all. And this, first of all, further underprices storage, but second, it creates the incentive that miners have the incentive to discriminate in favor of storage gas heavy transactions rather than computation heavy transactions, because that way they reduce their uncle rate. And this basically means that the optimal strategies for miners are weird stuff that involves re-executing every transaction, having lots of spare computing power.
And the storage bomb attack, if the gas limit is already full, so it's a period of high activity, then miners do sacrifice the gas fees they would otherwise earn. But if blocks are empty or not full, then that difference, it's completely free for them to just blow up the state.
Yeah, totally. And I think one thing we've been talking about a lot at this workshop is sharding. And let's say you want to store a full archival history of all the shards, which maybe some archaeologists like me might want to do for some esoteric reason. Then I think this problem actually gets even worse because storage is probably going to get cheaper. So I guess I have 2 questions, and then I want to open it up to a more general comment period. The first one is, let's talk about Bitcoin for a second. Which of those pathologies that we've been mentioning do you think their model falls into or would fall into at scale? And all of them is a good answer, but at least provide some intuition for why maybe. And the second question is in the equilibrium of long term, if the current codified protocol sort of is allowed to grow to, let's say, $1 trillion market cap, what do you think miners will be storing, and how many copies of whatever they're storing will there be in the world?
Yeah, so as far as Bitcoin goes, I'd say I definitely say yes to storage being underpriced in an absolute sense. I'd also say yes to clearing not being sufficiently incentivized. And I mean, like, I do know there's like that fancy magic about how SegWit is supposed to somewhat improve that, but like that doesn't come nearly close to being optimal. The third, I mean, as far as like state size misalignments, probably though much less so because Bitcoin has fairly like practically speaking has very low uncle rates even with full blocks. One of the reasons why I think it's mitigated in Bitcoin is because there basically is like one category of usage, and you can't. There's not really a distinction between kind of space filling usage or state filling usage versus the kind of like computation intensive usage. Like even the operators aren't state heavy; they're history heavy. Well, yeah, I mean, that's part of why the operator was created, right? To have prunable output so that it would not be state heavy. Basically, I think Bitcoin does have all of them, but like the sheer simplicity of the protocol base does kind of, in practice, reduce the extent to which a lot of it is an issue. Though I do wish they had like a Satoshi rent. As far as Ethereum goes, like I think we are at the gas limit already, right? So like, if the protocol doesn't change, then realistically in a decade the state will go to 100 years and like 100 gigabytes, and then history will go to like close to a terabyte, and we'll have a somewhat smaller number of nodes than we have now, and transaction fee prices may be higher, or they may end up going to zero because everyone just moves to EOS.
Yeah. Well, there's another kind of more extreme point of view, which I don't remember where I heard it. It was basically saying that maybe we're worrying too much about the growth problems because of like, you know, I remember I've been promised that there will be some fiber optic cables with unlimited bandwidth everywhere in like 5 years, and then everybody will have like terabytes and terabytes of storage, and then everybody will have something else, and then maybe what we do, if we worry about this storage growth, it's like the people in the Stone Age worrying about running out of flint for our civilization, where we don't actually need a flint. So yeah, there's another extreme which is worth exploring, because are we worrying too much about it, or?
I'm inclined to disagree, because even if, let's say, we get like suddenly, ding, technology level 6 unlocked, and we now all have like gigabyte internet connections and terabyte hard drives. So first of all, like all of these arguments will still continue to exist. They'll just exist on different margins. And instead of people complaining about like storage getting filled with like account entries, people will be complaining about storage getting filled with like people shoving their tweets into storage because they want their tweets to be accessible by the network more easily than through whatever the protocol is for grabbing history. And also with sharding, like basically, remember sharding is quadratic, so if computers become 10 times better, then the capacity of a sharded system could potentially improve by a factor of 100. So, like basically in all worlds, I think all of this, or in basically all realistic worlds, I think this stuff continues being important.
Regarding the worrying too much, I don't think so, because otherwise you get applications like Electron that eat like 200 megabytes just for a tray app. And we also have a mobile client like Status, and you can't just have a huge RAM on the mobile.
The reason why, I think the reason why something like Electron takes that much memory is not the technological, well, it's sort of technological progress, but here, because the computers are becoming faster, then the programmers don't care too much about the performance, because they think it's like we're going to just write on a Moore's law. And that's why you've got operating systems loaded up and things like this. But if you do kind of spend time on optimizations and writing proper code, then you can go a really long way. It doesn't stop. It doesn't stop to be amazed how people think that the computers are really slow, but they're actually quite fast. And the reason why we think they're slow is because the software is rubbish.
Yeah. Because the incentives are wrong to make it better.
Exactly.
Right?
So I remember when I was at like university and we were going to this like programming competition. I remember vividly that moment where they usually put up the quadratic complexity algorithms, and it will say, yeah, implement it, and the runtime limit is like 10 seconds. If it's over 10 seconds, then it failed the test. And you normally realize it, but okay, if you have a quadratic complexity algorithm, it would definitely fail. If it's linear complexity or n log n, then it will be fine. But then 3 years later, and we really tried to do linear complexity algorithms, 3 years later, that didn't matter anymore. Quadratic complexity flew through the things, and it was actually difficult to find the challenge where the quadratic complexity algorithm would be sufficiently slower than the linear complexity. And it was kind of depressing because the people just wrote whatever they felt like, and then it will pass the test.
Yeah.
I will say that for bandwidth particularly, there's less room for optimization because like ultimately a byte is a byte. I mean, there are still fruit that I think we haven't claimed. Like, do we have network level compression yet? If we do, then like even that was fairly recent, right? So,
Network level compression.
This is snappy. Yeah.
right. Okay.
And something I want to note is that, like, there's this kind of assumption around that, like, after scaling or with bigger blocks, that like fees will be lower, that rent will be cheaper. That's not like fundamentally economically a thing. Just because you increase the supply of something doesn't actually necessarily mean that the demand won't increase by at least as much. So a nice example is that like as we make more and more efficient engines, actually we don't use less fuel, we use more fuel because we create just a huge number of these engines because they're useful in lots of different places. And so like efficiency may just mean that the CryptoKitty horde will get. So sharding might just mean that the CryptoKitties just expand to fill the void, and then we have the same threshold equilibrium price for breeding CryptoKitties, no matter how much storage we have. It's very, very possible that like the limit is just how much people are willing to pay for CryptoKitties, and then it'll just fill up. Don't take it for granted that it's going to be cheap just because it's scalable.
Though if that's true, then that means we'll have more than enough money to use all the transaction fees to pay for Casper rewards, and we have to get to not be worried about that at all.
Yeah, the revenue, there'll be lots of transaction fee revenue in that case.
Yeah. So that's a happy dystopia. We can also like make a lot of the transaction fees get burned, and then like either supply can decrease.
Yeah, I mean, I'm all about not giving miners or validators any money.
Right. Mm-hmm. Yeah, you're about giving hodlers the money.
No.
That is what burning is.
Unfortunately, I'd rather, but
Right.
We're stuck with no good options here.
Then I'd like throw ETH into, have the ETH go into it too, but that's hard to make decentralized.
I just don't trust any of these people.
Thanks, Vlad. All right, so all the people that Vlad doesn't trust, I kind of want to open this up to the whole room and maybe get some opinions, some perspectives, some questions, anything you guys might want to say. I have some prompts up here, so if you like any of these, you can kind of answer it or ask it again or run with it. If not, feel free to also say your own things. Don't make me pass the mic around, please. Yeah.
Can I just bring up maybe the elephant in the room? I'm not sure if you mentioned stateless clients as an alternative to storage rent.
Yeah.
I can reply to that.
Sure.
So I mean, that is definitely something that we've spent a lot of time thinking about. I think the reason why we migrated from stateless clients or from a stateless client dependent model to rent again is basically because well, there's a few things. One is that like basically a stateless client architecture ultimately still requires a kind of state storage market to exist on the same level, so or on a second level. So you're not reducing the complexity, you're reshuffling it. And also, like basically, also it reduces censorship resistance because like every client has to like in a stateless client model, you have to specify your access list. And if you specify your access list, then people can discriminate against like attacks that touch the downs and so forth. And like granted, you know, if there are limits to that level of censorship resistance, as Phil wrote about like about 2 years ago, but like those limits can like you actually can get even more censorship resistance out of that property, especially if you allow asynchronous scheduled transactions. Whereas with a model that requires access lists, you basically throw all of that away. Another point was that, like basically, users and the user and client experience would suck because they would have to, like, first of all, engage in all these second layer markets, and there would, like, for like applications, a lot more applications would have to contain, like, basically weird kinds of internal economic engines that keep on paying people off as through the client, and users would have less certainty over exactly how long state that they sign up, that they put in would be available for. And I mean, there's also a complexity that has to do with, like, basic with stateless clients, for example, there is the possibility that portions of the Merkle tree will become inaccessible because that's kind of what you're designing the model around. And once that happens, then like there's a bunch of algorithms that stop working. Then you have to worry about, oh, what if some Merkle branches disappear and that suddenly makes an entire range of addresses inaccessible? That precludes the possibility of data availability proofs over and proofs of custody over state. So, like, it does make the situation more murky. And even in this model, right, if you want to, we could totally have a system where the state storage is like constricted to be very small, like thinking in like 32 megabytes a shard. And if you do that, like if you push to the extremes, then like you could encourage a very, very large portion of users to like basically any kind of non-trivial contract to just have 32 bytes of state and rely on Merkle proofs instead of doing what they're doing now.
Yeah, so I think one interesting question I heard earlier, just really quickly, was like, why not just use Swarm or another one of these second layer markets that have figured this out? And I would say the same thing, like in order to use something like that, the Ethereum community would have to ask itself, like, is this incentive model something we're okay with in the long term? Otherwise, people will lose data and the whole system will look bad. And once you've sort of answered that, you've solved most of the hard problems that you need to actually have ranked, so might as well do it in the protocol.
Yeah, I would argue that shuffling that complexity from layer 1 to layer 2 is better, because with storage rent in layer 1, I mean, that's just like the layer 1 protocol, you know, pulling in Swarm or Filecoin, you know, and then, you know, now Ethereum and Swarm Filecoin at layer 1, it just seems like a lot of complexity to pull into layer 1.
I was just going to say about the, what Charlie said about like 32 bytes storage on the blockchain and everything is off-chain and then providing the proofs. So what it would mean in terms of the client implementation or in the storage, if you look at it, if you remember the diagrams where today I showed you that there's 43 gigabytes of block bodies, and the block bodies actually include the transaction, which include the inputs to the transaction. So what you're doing is that you're shifting a lot of storage into that part of the pie, because you will still store, like probably some of the clients will still store all the blocks, and then basically all that storage will go to the blocks where it's not directly queryable, but it will still be shuffled around the network. All these inputs like Merkle proofs, and then like they will still be shuffled around, but they will not be queryable in a direct way. And I was going to answer the thing about Plasma, because a lot of people are asking, not Plasma, Swarm, because a lot of people are asking about like whether Swarm can solve this. And this is my personal perspective on this. because I did try to think about how the swarm incentive could be solved, and eventually whatever I came up with looked like plasma. So then I realized maybe the swarm has to have a plasma chain, and then it might solve most of its problem. I've already told it to the swarm guys, by the way. And another thing I was going to say, yesterday, where I came up with another idea during our Beatles talk about how to incentivize the nodes actually to store the data, not through the rent, but actually by using interactive proofs instead of non-interactive proofs. Which the idea is that if you want to query the state from me, I will give you the state, the part of the state and the proof, but the proof will not be, the proof will be interactive, which means that you will not be able to prove to somebody else the same thing. It's only between me, you and me, and you will pay me for that. And I know it will be good for me because if somebody else wants the same thing, they will have to pay me again. So if a lot of people ask me about the state, they will have to have an interaction with me and I will pay for that interaction. So if you take the state, you can't go to Vitalik and say, here, I get the state from Alexei, and say, oh, I don't trust you because I didn't have interaction with him. So that could be the way to avoid the whole problem of rent.
I just want to respond to Casey here. You know, I mean, I kind of agree. Is this on? I kind of agree that the complexity is unfortunate, but like the hypothesis that's motivating on this is that it's like not sustainable to not have rent from there on. Like if the state gets too big, I'm pretty sure everyone has like some threshold where like they would regard the state as too big. But like there's no real way to deal with that. Whereas like, but rent can force a kind of competition for the space, where like you know they can't get to.
I think like the stateless client world, right, is a world where the state can and does get arbitrarily big, but like no one has to store that much of it.
An L1,
Yeah.
there's still some state there. You know, so.
No, like the point is that like whatever like the state that everyone needs to store is 32 bytes.
For every account,
No,
32 bytes.
no, 32. Well, like Casper validator data, and then for like other accounts, they just literally just 32 bytes. Because like users are themselves responsible for maintaining their own local branches. Like that is the stateless client world, right?
I mean, it's like a super radical.
Sure. Yeah, it's like it is super radical, but then I guess so. I guess the question is like there's clearly I feel like two very radical directions. Where one is that and then the other is the one where the state is like the state is completely tiny and people like basically have to use layer 2 constructions in order to do anything, and then there's a bunch of possibilities in the middle. And there's obviously the third quarter of the triangle where like we force everyone to store the state and then it just becomes like clunky and centralized. So like I do feel like there is an entire trade-off triangle between the three of those, and like I get the wisdom behind some hybrid being optimal.
Layer 2 is going to exist now.
Yeah, totally. Well, okay, so we don't have layer 2s for like that kind of layer 2 now.
No, I know. But you could implement it as, you know, no hard fork required.
Oh, totally. Agreed.
So, I know this solves only half of the problem, but what happens if we take a different gas price for state storage? So we create a secondary market for state storage, and then have like, so you basically have computational
Pricing and you have storage price. So I think that was proposed several times, and I think it is intuitively kind of clear that the price of these should not be some fixed ratio because the costs kind of change differently.
So for what it's worth, right now I actually favor the storage price being a fixed amount of Glay.
Really?
Yeah. Literally a constant. Yes. So I know this sounds like it can be adjustable in the same way the gas valve is adjustable, but that's the extent of it.
Oh, that's not fine.
No, yeah. No, like, So yes, exactly. So I know this is kind of surprising, but I have thought about this, and I have kind of quite a bit of reasoning for it. So basically, one important thing to realize is that like transaction fees in any realistic long-run equilibrium are and will continue to be a lot more volatile than you might think given historical experience, right? And we kind of saw the first glimpse of this at the end of 2017, but there will be more. And part of the reason why I think people got complacent about transaction fees before 2017 is that like if you look at the graph of Bitcoin transaction fees and Ether transaction fees in USD, it actually does manage to be reasonably stable, at least like more stable than any other variable in crypto. But the reason why that's true is basically that in those eras, neither Bitcoin nor Ethereum blocks were full, right? And so basically what happened is that miners charged a minimum gas price, and the minimum gas price that miners charged was basically set by a political mechanism, right? The political mechanism basically is if the transaction fee gets too high, people organize and complain, and the cartel of miners goes in and drops the number a bit. And this actually happened several times in Bitcoin. It actually happened several times in Ethereum, and it actually did and because it is a political mechanism, it did end up creating this kind of pressure towards stabilization, right? Now, in the long run, we cannot expect this to continue, basically because blocks are full, and blocks will continue to be full, and the gas price will end up getting set by whatever the volatility and demand is, right? So the challenge, the problem basically is that, so first of all, transaction fees are going to get very volatile, right? And in general, like in the case where the crypto adoption increases by a factor of 10, like first of all, you can expect price to, like as a first approximation, to increase by a factor of 10. And you can expect the demand curve for sending transactions to go up by a factor of 10. So, like in this full block situation, the impact of kind of this common variable of adoption on cryptocurrency price volatility and transaction fee volatility is basically the same, right? So, in the long run, I don't expect Ether to be more stable than, I don't expect Ethereum transaction fees to be more stable than Ether. That's one thing, and then after that, then there's the other issue, which is that basically the social cost of including transactions that do computation in blocks is at least at the upper end super linear, right? So like the cost of increasing adding going from 0 million gas to 8 million gas is like one variable. But then the cost of going from 8 million to say 32 million is not 4 times worse, it's more than 4 times worse. And the reason why it's more than 4 times worse is that it has substantial probability of just breaking the network. So so because of that, it makes sense to have an equilibrium where basically your fees go higher the more existing usage there is. And so the vertical supply curve that the protocol presents actually is kind of closer to optimal. In storage space land, actually, if people start temporarily using 4 times the storage, it's not that bad, right? Like if the size of storage goes up by a factor of 4 or even 10, nothing breaks. Things do get inconvenient, and it's really not nice, but nothing breaks in the same way that things break if the uncle rate goes to 80%. And so because of that, basically the social cost curve is much flatter, and so it makes sense for transaction fees to be flatter as well.
Have you thought about rent price retargeting?
Targeted to what and by what?
Yeah, exactly.
Basically what do you target it to? And another important thing is that there are greater, at least I feel there's greater kind of, it's more of a bad thing for rent prices denominated in ETH to be volatile than it is for transaction fees to be volatile. And the reason basically is that rent prices are something that there are a lot of people where they're pretty much stuck and they have to pay it regardless. And because they already started some application, they already have some contract that's out. And like basically having volatile rent prices makes it more difficult to plan and like have a hard guarantees that this contract will exist definitely exist up until some particular date.
But if there's only, like if we want to bound state space.
Yeah, so I'm
then-
saying that because of my arguments about social costs, we don't want to bound state space.
Right, well, I hear you, but if we do want to bound it state space,
If
then
we
it's like
do wanna
super
bound
hard
state
to
space,
give
then we
people
don't.
this
I agree,
guarantee
yes. I
that,
agree.
like their strong contract is going to be there because like they're competing with everyone else for that
Yeah,
space.
no, I fully
And they
agree,
have to
and this
actually
is a
like,
great
pay
argument
more.
against wanting to bound state space.
But you know, decentralization.
No, but like the
1
point
megabyte
is
blocks.
that like, well, the point is though, because the social, like basically, like you have to think sort of not on the first derivative level, you have to think on the second derivative level. Like I know it's kind of hard to picture in your head because our like primate brains are devolved for second derivatives, but like the idea is, right, that let's say some given state space level gives us some level of decentralization. If we have like, if we have a fixed gas price, then there is some probability we'll overshoot and we'll have less decentralization, and there's some probability we'll undershoot and we'll have more decentralization. And so the risk on one side is basically kind of balanced out by the possibility of benefit on the other side. And the reason why that's true is because, like, basically the social cost curve isn't super linear, which means that like the risk on one side isn't actually kind of that much bigger in magnitude than the happy case on the other side. So basically, if we're afraid, we just like set the fee higher.
Are you satisfied with that? No. Okay.
So just to be clear that I understand here, if the price of rent wasn't volatile, would you still feel this way?
If the price of rent was what?
Like if we just like knew the price of rent, that would just like discourage the apps.
Oh, but if we knew the price of rent wasn't volatile, then that also means that the demand curve isn't volatile, which means that like any policy will give stable outcomes.
Not if more than some size of state isn't stable. So I'm saying it's like, oh, you know, if we want to bound, if the goal is to bound state size, someone's gonna have to. At some, if once it gets above the target amount, like some contracts are gonna have to go.
Yes.
And if it could be done in a way that's low vol, like would your argument still hold?
If it was low vol, like what do you mean?
Yeah, it was like just clear who the lowest bidder was.
No, it's obviously going to be clear with the lowest bidder, but the point is that it still takes away from like certainty of being able to say, I'm shoving this thing on the chain and it will definitely be alive until October 29th.
As long as I'm not the lowest bidder.
No. That's not the same degree of planning ability, right?
Yeah, sure. But you know, this congestion. If everyone plans to live on Ethereum, how will there be enough room for crypto kitties?
Well, I think the point is that if everyone lives on Ethereum, then there'll be lots of people paying these fees, and so ETH will get burned really quickly, and so the price of ETH will go up, and so the fee will go up.
Oh, sorry, why would that make the state size bigger?
No, the point
Or-
is that
or
lots
like
of
let us
if, like,
support
if,
the
if
state size?
suddenly the demand curve just suddenly becomes super huge, then like basically the level of fees paid will be really, really high, right? And so because of that, the supply of ETH will start going down. And so the price of ETH will start going up in anticipation of future supply decreases. And so the price of ETH going up will by itself help to discourage more people from joining the demand.
But so you're saying that the price of gas is going to be volatile anyways?
No, I'm saying that, well, the
So
price of
rent.
ETH, so I'm saying that, like, basically, especially in a kind of end run scenario where the price of ETH is kind of more based on, like, direct usage demands than, you know, whatever it is people hold ETH for now. Like, basically, the idea is that, like, we get some kind of security back, we get some level of assurance back because of this mechanism where if transaction fees are in high demand, if everyone wants to if everyone wants to store things, then, well, okay, I guess like the ultimate argument, right, is that there is ultimately an upper limit, and that upper limit is basically connected to how much the total supply of ETH and like the idea that you can only burn so much, right? But like within that, there is this fact that as the supply of ETH goes down, that makes the price go up, and so that makes storage more expensive. And that.
Okay.
Well, so there is there is
bound
technically a
the
bound,
size of
but-
the trolling
Yeah.
today. All right. Yeah, we'll just finish this, I guess, and then we're almost out of time. So one thing I want to finish on, I want to make everyone in the room talk. So I'm going to pass around a mic, and I want everyone to answer one of several questions. Number one, if you're a dev or a researcher, like how urgent is this problem, and how quickly do we need to move? And if you're not a dev or a researcher, like what would make you feel good about paying rent? Some potential ideas include ETH being burned to increase the price of your HODL. You know, renaming
Or
it to something.
Make sure that Casper will continue to be secure without issuance.
Yeah, make sure Casper will continue to be secure without issuance, so like the Kevin Pham, like deflationary model.
Yeah, I love it. We're going to be more Kevin Pham than Kevin Pham coin.
Exactly. Or maybe you just have like a really nice warm fuzzy name for rent that you want to promote, because I think we could use a better name than rent. I don't think people like the word rent. So, I don't know, unicorn tax or something? I don't know, give you
Let's use the word
ideas.
taxes, because the libertarians will love that.
Okay, yeah. All right, cool. So I'm actually going to pass this around. I wasn't kidding. You don't have to say anything. Okay.
Sort of UI UX related question is that how not to miss the deadlines when the rent is due, if it's rent, and that sort of global links to the huge idea that transactions in Ethereum are only originated currently, and maybe we need to figure out something without the deductible or just like permissioned deductions on the Ethereum accounts. Maybe only for rent, maybe for some other users. I can imagine a couple other users which will be helpful.
All right, so I'm probably more of a developer, and I'm kind of a little bit an optimist in this, simply because first thing, you have a set of technologies somewhere, right? And they reach a limit, and then new technologies get developed, and you can throw them at an old problem and get a better solution overall, right? That's where we are right now with crypto economics and Merkle trees and all that stuff. Second thing is that there is a couple of potentially feasible layer 2 solutions being developed for this, and they might come along like not too soon, not too far from now. And third thing being that like as this becomes a bigger problem, the incentive to fix it grows, and like the panicked feeling amongst developers will grow as well, meaning that the solutions we'll provide will be more and more tethered to reality.
Or they'll be hacked together.
Yeah.
A fuzzier name, how about storage dues or storage association fees, something?
Storage Association Fees, SAS. I think that's taken already. It's like a homeowners association for Ethereum.
I have two comments. It would be interesting to see if this wouldn't be just slapped on like the S-Store costs, but rather it would involve an entire redesign how S-Store works in terms of cost and everything else. I don't think it would be good to have like another extra rule just slapped on top of it. And the second comment, I would be wondering what kind of patterns this could spring in languages, how languages would work with rent.
Yeah, rent DSLs, that's really cool, yeah.
So I also have a question, your sort of second category of questions about the controversy. At least in the Ethereum world, gas doesn't seem to be particularly controversial, so I'm kind of wondering why rent is so controversial, and is it rent as a concept, or is it more how do we add rent onto a system that doesn't have it today?
Like the answer basically I think is that the main thing that causes rents to be controversial is that it introduces the possibility that if you have some accounts and you don't pay rent for it, then the account gets deleted. And like you can mitigate that, and like there's like 5 different ways of mitigating it. One being like charging a fixed rent price so you can calculate how long you'll have to live more easily. Another is the hibernation mechanism I wrote about in youth research. But like still it is a very fundamental change to guarantees. Another is that it makes it much harder to write safe, secure contracts that have unlimited storage size. So if you look at like a lot of the more complex DApp contracts that get created, like they just like throw stuff around the database willy-nilly, right? And but whereas in a rent world, if your application has a lot of internal state, you have to kind of do a lot more accounting of, oh, which user is this internal state assigned to? Do you have to like pass on the rent? Do you have to delete the state if that user ends up not paying up? Or the other alternative is that you have to kind of move objects out into other contracts that you have to create like abstractions that say this is a state object owned by some user and it could disappear at any time. So basically it makes a development model considerably more complex.
So I think that's like from the development side, that's the reason people are maybe against it, but from a user side, I think it's more a few different reasons. One, no one else does it. So it's very that I know of. It's very it's a whole new concept. It's like, wait, I thought things that I put there were there forever. And then it's also, I think, plays on this idea of immutability and how they think that if they do an action, it is there, done forever. And I think there's just some public perception as to what this thing can and should be, without regard to the technical limitations.
One more quick question. Why not flip the model around and like make storage store very, very expensive as if something was going to be stored forever, right? To sort of charge all the cost up front and then incentivize people to more aggressively free storage to get that money back if they don't need to store something forever.
So do you mean by having like a bigger gas cost for storage and a bigger rebate or like
exactly
yeah, so you know what does this do to gas token, Phil? Same
Let's take this deal and let's say there's an ETH denominated fee for submitting something into storage and then you get some kind of ETH refund if you look there.
So you actually get ETH if you clear, a fixed amount of ETH when you store, a fixed amount of ETH when you clear, so you can't earn it. Okay, well.
I think one of the complaints I have with this scheme and a lot of other schemes I've seen that are like based around like locking up funds or something similar, like anything where you sort of pay up front forever, is that somehow it feels wrong to me to assume that we can predict future costs. So we may be like over or underselling that space. So if we're sort of overselling it, then the user would actually save money if they were paying rent. And if we're underselling it, we're creating like potentially an unsustainable situation from later. And the way I kind of see these systems is that they should kind of be dynamic and like respond to capacity. And to do that, you need to sort of change these like dials a little bit. And at some point, you will be like over or underpricing, kind of inevitably.
Another thing to point out is that in all of these refund models, there's kind of a three-part trilemma, where there's three possibilities, right? So let's say you have an ETH or like some token-denominated fee for filling a storage slot. Then your question is, what is the refund for clearing? Option one, the refund for clearing is exactly 100%. If you do that, then like basically everyone who hodls Ether has no incentive not to hodl it in storage slots instead of hodling it in ETH. And so that creates a kind of like zero-cost spam vector. The second possibility is that there is no refund at all. But if there's no refund at all, then you have this problem that you're not incentivizing clearing at all. And then the third is that if you have some function that's decaying over time, then because the function has to be bounded above 100%, it's nonlinear. And whenever there's a nonlinearity, you have different users at different slopes of that line. And so that creates an incentive for a second layer arbitrage markets.
Just to give you a perspective from ex-finance guy. In the commodity markets, we have what is called the cost of carry and convenience yield. So basically, if you, let's say, store rice in a port and you want to trade it in the next 2 months, you pay rent on that. And so some keywords, you have forwardation if actually the rent is positive, but you can also have negative rent if people just want to not store it and want to sell it ASAP, like if it's you have expiration date, for example. And this is called backwardation. So if you want to find some idea of names, look into the finance world and Investopedia.
I have a question. I just thought, wasn't it that storage was designed to, Swarm was designed to solve this issue with growing database and storage issues on Ethereum? When we could integrate Swarm into Ethereum mainnet?
Sorry, the question is when.
So why not integrate Swarm with the Ethereum mainnet, and part 2, when is Swarm?
So part 2 is the one I was confused about, because I have no way to know. At least I don't know. I could probably find out if I asked the right people. Part 1, how does this change when we have Swarm?
Whether Swarm can help alleviate those issues.
Right. Well, Swarm kind of provides a layer 2 solution for storing these files, and provides kind of, you know, rent-like alternatives, and maybe even rent. But it's not going to do it for smart contract storage. And so, you know, you'll need to have clients that access this stuff and then feed it to the smart contract on an as-needed basis if the smart contract's actually going to have access to that data. And that's a bit complicated. So in the application, we'll have to have, you know, be online and be on Swarm and publish transactions. But I mean, I kind of think of it as being an independent thing. But if we were to have stateless clients, then I think that it would potentially help, or potentially could be a big part of the solution. Because in stateless clients, like, we have this big question about like how Rendex protocol is going to work.
So as far as I remember how the Swarm worked last time I looked, was that it doesn't give you the immediate availability of the data. You might need to do some kind of arbitration before you actually extract it from the storer, because the storer promises to store it, but then if it doesn't provide you straight away, then you have to do the arbitration, and eventually, if they want to win, they have to put up the data on the blockchain, but the smart contract can't really do that unless it's super asynchronous.
All of the data? Some of the data. Okay, that's good.
So I'm most concerned, I suppose, with how the users expect these systems to behave, as was mentioned earlier. And a lot of the rhetoric has been around particularly about immutability. And so when we're thinking about how we describe this stuff, I tend to agree that rent is perhaps the wrong word, because it has the wrong kind of connotations. And I've been sitting here furiously trying to think of like different alternatives. It's quite a difficult question. I think that's most likely, right? It's just that it has me thinking, you know, there's a guy who I quite like and follow, a guy called Jaron Lanier, who is famous for doing some early VR work and for being quite closely associated with Richard Stallman and the Free Software Foundation, who are all about, you know, free as in speech and beer. And Jaron Lanier sort of turned around in the late 2000s and said, actually, you know, this shouldn't be free as in beer, because you're actually, you need to pay for information, and we need to somehow find a way of getting that across to users. And so it seems to me like there's some opportunity to be like, this is the freedom cost, right? Because like what ultimately is the point of having immutability on Ethereum? It's so that you can assert your own version of history and agree on that history deterministically with a global set of peers, which is kind of like the root of at least the technical kind of freedom which interests everybody in this room, right? So like a fiefdom, or like a freedom cost, I don't know, something, fiefdom, yeah. So there's something there, I don't know.
Yeah, that's awesome. I like that perspective on it for sure. Yeah. Gonna come this way.
So there's a lot of like signaling externalities to consider whenever you want to like name or frame something, but like one direction to, when you want to frame like charging people something, like one direction is to frame it as like a membership or like a club like kind of a thing. And there's like, you know, there's again, elitist considerations, other considerations, but that would be a category of thought if you want to kind of reverse the thought or the sentiment around it. One other thought I have is like, this is very like hand-wavy, but like, it feels like we understand this problem relatively well by like blockchain world standards. And my like current bet would be if the situation is able to progress naturally, then like the inherent kind of forces will lead to a reasonable outcome. And so I'm almost like as interested in like what happens if there is like a storage bomb like attack sooner, or like right now the markets don't really work in a way where that seems to be incentivized, like performance and those kinds of things don't seem to really affect prices and other things. But as we've seen in the blockchain world a lot of times, it really only takes one event for the entire sentiment to change around that. So, you know, it's kind of like arguably like a black swan-y thinking where it's like, well, how much weight can you put on this likelihood? But if there is this kind of storage attack, let's say in 3 months, what do you do about it? I wonder how much we should be considering that possibility and that category of possibilities. And maybe it's just like, maybe this is just we hope this is able to progress organically so we don't have to deal with it. I mean, that's certainly happened in a lot of other circumstances.
Another thing worth pointing out is the hibernation mechanism. So like with the hibernation mechanism, right, like if a contract doesn't pay rent for long enough, then it's not like it dies forever, right? The contract can be revived, and it can be revived through this mechanism where basically you provide Merkle proofs of the original state and a Merkle proof that you did not revive the contract earlier, and that basically lets you bring the contract back. And so it's not so much as like a fee you have to pay for being alive, it's like a fee you have to pay to like maintain frequent flyer status. And if you don't pay the fee for long enough, then you're hibernating, which basically means the next transaction you do with the contract will just have to take 20 times more gas to include the Merkle branches.
So what I'm getting from this exchange is that we should call it a bespoke premium storage select fee. And then if you want, you know, a regular class storage, you can put it in Swarm or whatever.
Yeah. And
dirty
we can
thing.
have like first class storage, so like addresses with more zeros in front of them, like you have to pay more for them, but then at the same time, like clients are expected to already have those branches, and you have to pay less gas for actually using those accounts.
So they should be called miles.
They should be called what?
Miles, like a frequent flyer miles.
Yeah, exactly. Actually, no, I think that we can, if we have a mechanism where the amounts that you pay to access a storage slot is proportional to the number of like new Merkle tree nodes that you're opening up, which is realistically close to the cost that notaries would have to pay, then you basically get this kind of emergent like first-class storage, because whatever the kind of set of storage islands is that are most popular, those are the ones that are going to be more expensive, and the ones where if you're located right there, then you'll have the fewest Merkle branches that you have to open up.
Another idea is, instead of calling it rent, you can call it insurance, and you have some kind of mechanism that randomly destroys the account or contract that didn't pay any insurance.
There's a mafia model. It's a nice little token balance you got there. It would be a shame if you didn't pay the protection fee. Yeah.
From my perspective, randomly destroying things are perfectly okay.
Yeah, great. Yeah, I like it. Yeah.
So to me, the idea of the rent sounds natural, and I just wanted to add that to this hibernation mechanism. I mean, wouldn't it be also possible to, if a contract runs out of gas, then out of rent, then instead of like directly hibernating it, it could have some kind of deprecation period, so that, I don't know, for 3 months or half a year, or defined in blocks, it keeps going, but people would be notified early on that, okay, if no one is going to pay for it. Yeah. So then I think it would be like fairly okay for people to deal with that.
Your contract gets replaced with nothing until you just send the transaction that includes the Merkle branches to bring it back to life.
Yeah.
Well, you actually do need to have the Merkle branches for the latest, like the kind of pre-mortem state of the contract.
All right. So we're cutting into the break, guys. I wish we could keep going. And I'm sorry to you four guys that we didn't get to this side of the room, but maybe we can like have a little table over here during the break and we can keep arguing furiously about it. Yeah. Name suggestions? Yes, that's perfect. All right, thanks everyone, and thanks to the Corp guys especially.